Hello, this is Ms. DB. In this video, we are going to continue our unit on ratios, rates, and proportions with a worksheet about rates. So today we will write equivalent rates, find and compare unit rates, and we'll use rates to solve real-world problems. So what is a rate? A rate is a special kind of ratio. It compares two different types of units, like dollars and pounds, or boys and girls. So suppose you are buying turkey at a supermarket and you pay $12 for 2 pounds of turkey. That's a rate. The turkey you bought cost $6 per pound of turkey. That's another example of rate. That's actually a unit rate, and we'll talk more about that in a minute. So the word per is a good clue that we're talking about a rate. But also our first one was $12 for 2 pounds, so that can be used to explain rate as well. Equivalent rates. Two rates are equivalent. Equivalent is just a fancy word for equal or the same if they show the same relationship between two units of measure. So $12 for 2 pounds is equivalent to $6 per 1 pound. So here we're going to write with some examples, we're going to write some equivalent rates. Write an equivalent rate to 20 miles in 4 hours. Step 1, write it like a fraction and just ignore the miles and the hours, the units. Just write 20 over 4. Step 2, in order to make an equivalent rate, you can either multiply or divide both numerator and denominator by the same number. You can use any number to multiply. If you're going to divide, you want to divide by a common factor of the two numbers to make it a little easier to do. So in this example, I multiplied both 20 and 4 by 3. So 20 times 3 is 60. That's what I did right here. And 4 times 3 is 12. Step 3 is to write as a new ratio and add your units back. So this would be 60 miles over 12 hours. You can also write it in words. This would be 60 miles in 12 hours. So you can either write it like a fraction or a word, but do put the miles and the hours back, whatever your units were. There's another example with 16 pounds for $40. In this one, I decided to divide to get my equivalent rate. So I started by writing it like a fraction right there. Then I decided to divide both of them by 4. So I took 16 divided by 4 and got 4, and 40 divided by 4 and got 10. So my new ratio would be 4 pounds over $10, or 4 pounds for $10. If you want to write it in words, you can do that as well. So now on your worksheet, you're going to write an equivalent rate for each of the given rates. And we'll follow these steps here, same steps. Let's do, I don't know, number 5. It says 18 inches for $2. So our first step is to write it like a fraction, ignoring the units. Now I could write 2.00, but that's the same as 2, so to keep things simple, I'm going to do that. Your next step is to decide whether you want to multiply or divide by the same number. Either one works to get an equivalent rate. I could multiply both of them by a number. I could multiply them both by 2. And if I did that, I would get 18 times 2 is 36. 2 times 2 is 4. Then our last step is to write that as a rate, putting our units back. So this is 36 inches. And we can write it like a fraction over $4. Or we could write this in words and write 36 inches for $4. Now you can also divide your numerator and denominator by the same number. We saw that earlier. Let's try one where we would divide both of them. How about number 8? So again, we start by writing it as a fraction. Then we need to divide both top and bottom by the same number. You can decide. I'll just use 2 again. I'll divide the top one by 2 and the bottom one by 2. You might as well keep the numbers ones that you can do easily rather than making it more complicated than you have to. So 20 divided by 2 is 10. 4 divided by 2 is 2. Then we put our units back on to write it as a rate again. So this would, the equivalent rate to 20 miles in 4 hours would be 10 miles in 2 hours. And you could also write that in words, 10 miles in 2 hours. Now, when we were doing this problem, you might have thought to yourself, why don't you just divide them both by 4? That's the greatest common factor. That would be another way to do this problem. Let's look at the same problem, but this time divide by 4. So if we had divided both of them by 4, we would get what's called a unit rate. If the denominator, the bottom number, is a 1, that's called a unit rate. So this is 5 miles in 1 hour, and that's a very useful thing to know. Because if somebody says, well, I don't really know what 20 miles in 4 hours calculates out to, you could say it's 5 miles per hour. And we like to have things as unit rates. It's handy and it's easy to figure out other calculations about that rate. And that's what our next part is about, writing rates as unit rates. So again, if the ratio, the rate, has a denominator of 1, then that's called a unit rate. So here's the same problem we just did. Same exact problem. If you divide both the numerator and the denominator by the bottom number, by the number that is in the denominator every time for a unit rate, that will give you the unit rate. Now, sometimes, like in this example here, you get a decimal number. That's okay. So in this problem, we have to divide both top and bottom by 40. And when you use your calculator and take 16 divided by 40, you will see that you get a decimal number, 0.4. So we write that as 0.4 over 1, and then we put our units back on, and that means that you get 0.4 pounds per dollar. But that's nice to know because now you know how much a dollar will get you. It'll get you 0.4 pounds. So that's called a unit rate. Unit rates sometimes have decimals as part of their rate, but it's still a rate. Let's see, how about number 11? 54 hot dogs to 12 minutes. So what do we do first? Should I go back up here? Write it like a fraction. Ignore the units. 54 to 12. Now you are going to divide both numerator and denominator by the number that is in the denominator. The denominator is the bottom number. It's a 12. We need to divide both 54 and 12 by 12. Well, the bottom is easy. 12 divided by 12 is 1. That's why we're doing this, to get 1. So 54 divided by 12 is going to be a decimal, but that's okay. It's 4.5. So 4.5 over 1 is our rate. And just like with ratios, because a rate is just a ratio, we want to leave the 1 there. We don't get rid of it and just say this is 4.5. We need it because we are talking about two different units here. We are talking about 4.5 hot dogs per minute, per 1 minute. And you can write this like a fraction, but you need to label it. Or you can write 4.5 hot dogs in words, like in a sentence, per minute. You don't have to say per 1 minute, you can just say per minute. So I'm guessing that this was like a hot dog eating contest, and this person could eat 4.5 hot dogs per minute, which is more than I could do. And you'll do the same thing for each of these other problems. All right, now on these problems, you're going to write a unit rate for each, same thing as before, except it's in the middle of a real-world situation problem. So you need to read it, figure out how to write the fraction, then divide numerator and denominator by the denominator, the bottom number, to get your unit rate. Let's look at number 20. Mrs. Jenkins paid $50 for 40 square feet of carpeting. What was the cost per square foot of carpeting? So it's really saying, what is the unit rate? So we write it as a fraction, 50 over 40. We can ignore the units. Then we divide both of the numbers by the bottom number, the number in the denominator, and then we figure out what we get. 50 divided by 40 is 1.25. 40 divided by 40 is 1. And then we put back our units. The top number was in dollars. The bottom number was square feet. I'm going to abbreviate to SQFT, square feet. So another way of saying this would be 125 per square foot. So unit rates on these. So that's the cost of her carpet is $1.25 per square foot. Once you have unit rates, you can compare to find out which is the better buy. This is something that when you're shopping, it's nice to know which one is a better buy. Is it a better buy to buy the one with more in it, or the one with less in it, or at a different store? So we'll write these as unit rates, and then we'll compare. Here's an example. Felicia needs to buy sugar. She could buy a 16-ounce box of sugar for $1.12, or she could buy a 24-ounce box of sugar for $1.44. Which is the better buy? How many cents per ounce cheaper is that buy? All right, let's look. Step 1, write the first option as a unit rate. So we write it like a fraction. That's where I am right here. Write it like a fraction. 1.12 over 16. Then we divide both top and bottom by 16 because that's the number in the bottom. Then you have to get your calculator out and do 1.12 divided by 16. And that equals, oops, I accidentally hit divided by twice. I'm just going, or hit equals twice. I'm just going to redo that. There it is. So 0.07. And another way of saying that with our units on would be 7 cents per ounce. That's pretty cheap. Now let's do the second box of sugar. That one is $1.44 for the box for 24 ounces. So we write that like a fraction. I want to get out of that equation editor thing there. So 144 over 24, and then we divide top and bottom by the 24, and then we use our calculator again. So this time it would be 1.44 divided by 24, and it's 0.06, so that's 6 cents per ounce. And then there was one more question, I don't know if I answered it on here, that said, how many cents per ounce cheaper is that by? And that answer would be 1 cent. It's only 1 cent cheaper. So the better buy is the 24-ounce box of sugar, so you would have to answer that question as well. Maybe it's on the next page here. Yep, there it is. The 24-ounce box of sugar is the better deal because 6 cents is less than 7 cents. And it's cheaper by 1 cent. So you're going to do that for these last two questions, is decide in number 22 which is the better cheddar cheese to buy. And in 23, we're going to look for who's driving faster at a faster rate of speed. So we'll write them as unit rates and be able to compare from there. If you get stuck on this, let me know and I'll give you a hand. Thank you very much and have a wonderful day.